All right. Well, I'm making a quick video for my presentation. I know it wasn't required, but I just thought it'd make a lot more sense if I could do a presentation. So real quick, this is my project. I created a database that could be used for a business that manages vending machines. I'm doing it because I'm doing a senior project this coming semester where I'm going to create a payment setup for a vending machine that only takes coins. So a lot of these tables I won't use in my project, but since this final project required at least 12 tables, I decided I'd expand it and make this a database that could potentially be used for like a bigger company that has multiple vending machines. So this is the ERD. The important tables here, well, they're all important, I guess, but the main ones is that there's a machine table. It just says machine ID, the name of the machine, and the address. The name is just a column. The address is a foreign key to the address table. Um, and then machine can also have transactions attached to it. There's no foreign key in the machine table for transaction, but yeah, if a customer makes a transaction, that transaction would have a machine ID um, associated with it. That's how it's connected there. Machines have machine slots, and they also have managers assigned to them to manage the machine. So like a machine slot is just like the slot in the machine where the snack is. So this is a way to keep track of inventory. It has a many ways. Every machine could have more than one have different amount of slots. So I didn't do like a slot thing in the table itself. Made a separate table for that to keep track of. So you can add as many or as little slots to each machine as you want. And then this cart item here is just if the customer wants to create a kind of like a on Amazon when you have a cart, same thing. It would just be if you buy more than one snack in the vending machine, you have a cart that just has an ID and a customer ID associated with it. And then this is how you add items to the cart. And it's connected to the machine through the ID, this foreign key here, and then you add a snack ID and how many of them you want. That's how that works. We have a payment vault. I don't think I would actually do this in my real project, but I figure since uh, this is for a potential business, this is where if a customer comes, they work somewhere and they use your machines a lot. They don't want to have to keep putting their card in every time they use the vending machine, so they can create an account that just has their name, a password, an email, and with that account they can add their cards to the payment vault so it's remembered when they come back. And then transaction address. The expense here is the only table that doesn't have any other tables connected to it. This is just a table that you can use to track business expenses, like if a machine breaks, when the machines need to spend money to buy more snacks to refill them, things like that. And then the snack ID, the snack table is a pretty important table. This is where you keep track of what snacks can be in the vending machines. Each vending machine will have its own inventory via the machine slots. And then you'll have a table that houses a bunch of different snacks that may or may not be in the vending machines, but you can add them to the vending machines by connecting them with this machine slot. It just has a name, a cost, a brand, a country, and how many have been sold. That way you can, if you're a business owner, you can keep track of which ones are popular by seeing how often they're sold. And then this manager here is just each machine would need someone to manage it to add more snacks or fix it when it gets broken. And so I just created this really simple table, just a manager, an ID, has a name and ID. And then in here, this is where they can keep track of their time. If they clock in and out, that just has a manager ID foreign key, so you know which manager it is. And then there's a many-to-many relationship in this table I wanted to create just so I could demonstrate a many-to-many. I decided that managers could be assigned to machines. They could have more than one machine assigned to them, but a single machine could also have more than one manager assigned to it. If there's two people working in the same area, maybe one day it's their shift to go fill their machine, another day it's another manager's shift. So I have this table that kind of goes, it's a junction table in between manager and machine. So that way I can satisfy the many-to-many relationship by just having this table. And that's it for the ERD. The other thing that the requirements of this project asked for was a mock-up of the user interface and how it connects to the backend. So basically how the database is going to connect to the application we're building. And so since it was just a mock-up, uh, I created the start of an API that could work. I'm using a library used for another project. It's called Express, and a library called mysql 2. Express is basically a library that lets you write JavaScript functions and create an API quickly. And so the way it works, um, you create a connection to the database. I've got a config file that just has like the host name. So in my case, it's just localhost. The username of of the database and password and the database name itself. I keep that in a config file that's in a .ignore, so it doesn't get, I don't want to reveal my passwords to the world, but that way you can still connect. And then you just have these, app functions. This is a .get function, so it means that you're getting information from the database. So you put your SQL queries in like this. This is it just gets data from the customer table, and then it puts it on a port. So your application could use the data. So if you run it, just says your server is running on port 3000. So if you go to that site, if you go to localhost 3000/items, because that's the route, you'll see the items in the customer table right now. And so again, it's not the full database, but the requirement just asks for a mockup. So that is my mockup. It's pretty easy to add more, and you can do, instead of .get functions, you can do .post functions where you actually add items to the database, and those are very simple to do as well. So that is my API, my mockup of my backend to the front end connection. And then the actual test, the other thing I asked for is test and functionality. So I have basically in my project, I have a folder called SQL testing scripts, because the project wanted me to write tests for CRUD, create, read, update, and delete. So I have a folder for each letter of the acronym: create, delete, read, update. And each one of these folders has about 14 or so tests in there. One for each of the tables. So, and the way that works is pretty simple. Yes. So use the test, just make sure you use the vending database, and then you'll insert into a row. You'll insert a row into the address table, and you use some variables to store data about the table. So this function just gives you the last ID inserted, because that would have been the one you ran, or when you inserted into the table. And then I insert into a couple more variables to keep track of like the street address and the city. And so that way I can check to make sure that those things have been inserted into the table. And then if I run it and it worked, I get a test passed. And then when that's where it outputs that test passed. And then at the end, since these are just test rows, I don't actually want to keep on my database, so I just delete them from the database. And I could run the test again if I want. So that's how the test works. There's a bunch of them. They're all fairly similar. They follow a similar approach. They'll be obviously a little different if they're a delete, read, or something. So like if it's an update test, I need to create an expense. This is the update test for expense, for example. So you just insert into the row and insert a row into the table, and then same thing. You use some variables to store things, and then you do you need to actually do, and then you verify that it was added in the first place, but then you need to do the update test. So this is where you do an update statement for the row you just created, and then you test to make sure that it is now the table now reads as you updated it. And if it does, then the test passed. If it doesn't, then it fails. Same kind of thing. Let's see if there's something I'm gonna change here. Oh, expenses. That's because I'm a silly goose. It's called expense, not expenses. So I need to change everywhere that I put an S. Okay, I think that should work now. No, there's still on expenses somewhere. From expenses. There's still another expenses. Expenses, expensive. Where is it? On the set. No, from expenses. Okay. Anyway, sorry about that. I was trying to, it's good. I was told it's good practice to don't have plural names for your tables. And so I must have, when I wrote this test, I must have accidentally did expenses instead of expense. But as you can see, that test does work as long as you don't type expenses. Right, you type expense. So anyways, that's my project. Now on the, I guess the last thing, aside from tests, I also have in this folder called functionality, I also have some queries that demonstrate how to use all the tables. And so this covers all the tables in my database, how you would add and just work with the data basically. So yeah, I have like I don't think I covered this snack request table, but the snack request table is just a table that a customer could, if they if they don't see a snack that they want in there, they could send in a little email that says, hey, it would be cool if you had this snack in your vending machine. So anyways, this is just a SQL script that will show you how to make a snack request. So basically you need to have a machine first of all to make a request, because the customer would be making a request from some machine. So you need an address for a machine. That's why I do this, and then a machine. And then you create a snack request. And then if you just run this, it just kind of shows you that the customer requested a Reese's. They requested it at that machine. That's the idea of the request. And then that's just as a brand, and that's the date that they requested it. But there's other ones in there too. There's a little bit more complex ones like machine and machine slots. This query shows you how you can create slots into your machine. So basically we're saying we have 2 slots in this machine right now. There's 5 snacks in this slot, 8 snacks in that slot. They're both in the same machine. That's how you know, because they have the same machine ID. One's 22 and one's 23, so they're different snacks. So anyways, this is my project. I hope this was descriptive enough. And thanks for watching.